All right, like I mentioned a little bit ago, everyone is muted, so if you need to type any questions, I'll cover that here in a minute, actually. But let's go ahead and get started. So thank you for joining us today for the Oasis Sales Did You Know webinar series. This is our 8th one this year, and we're going to be going over design rule entry. So, as you know, we're a representative for Mentor Graphics, now Siemens. We provide all the tools in the full design flow now, everything from mechanical engineering through electrical design, simulation products. A little bit about Oasis real quick, if you're not aware. We have been a Mentor Graphics reseller now for over 16 years. We're also a Siemens reseller as well, so we're representing all the MCAD tools from Siemens, but we're the exclusive reseller for the mid-part of the United States, and you'll see that here in a second for all of the Mentor Graphics engineering electrical engineering related design applications. There's 2 people on the technical staff that work for Mentor Graphics or Oasis Sales. I'm one of them, Brent Klingforth. I've been here for almost 12 years now, coming up in October actually. And then we have Kyle Lake, who joined our team a couple of years ago to give us a little more depth on the simulation side of things and expand our capabilities to our customer base. So if you have any technical questions about the tools or would like more information technically about what I'm presenting today, or anything that you've seen in the past, or if you're a PADS Mentor customer today, you are more than welcome to email or give me a call, and I'll do my best to help you out. You may also know some of our sales staff around our territory. We have Derek Pop up in the Northwest, Lizzie Marsh down in the Southwest, Andy Bowe in the Upper Midwest, and then we have Pete Archelios down in Central South, and Rick Truza in the Upper Northeast area. That's all part of our territory. And then we have Jason Johnson as well in the Northwest, handling more of the PAD stuff, so he may be more of the person you're talking to if you need on-site visits or technical resources as well. And then we have our inside sales team, Fawn Chang and Dennis Reynolds. You may have heard their names before or spoke to them. They can assist with PADS evaluations as well as I can, and also get you technical resources if for some reason you can't get a hold of me. How to contact us. We all have our emails. Obviously, it's just our first name, last name at oasissales.com. But for sales information, you can generally go to Fawn and get help from her. As I mentioned, if you need to ask any questions, please use the GoToMeeting control panel window and type in your message. You can send it directly to me, and I will answer that question. More towards the end of the meeting, I want to keep things flowing since we're recording this, so that we're not interrupting things until the very end. But go ahead and type your question at any point in time, and I'll refer back to those at the end of my discussion here. If you were not aware of all the other webinars that we've done, like I said, this is number 8 in the series that we're doing. You can go and rewatch any of these from our website. Just go to oasissales.com, Oasis Events, and you'll see View Now there, and it will launch that up. So if any of these other topics here are of interest to you, feel free to review those and watch those at your leisure. So let's go ahead and get started. Our feature today in this webinar is, did you know complex design rules can be easy? This does not have to be a complex process in the design flow, like most tools make it out there today. So just a couple of quick bullet points, and then I'm going to go into just showing some stuff instead of giving you guys a bunch of presentation material. I'm actually going to go through some of the processes used that are better than what most CAD tools provide you today. So engineers should not have to just sit down and realize that constraints can be very difficult to deal with. Most designers that I talk to actually don't enter a lot of constraints in their designs because they don't want to go through the process of doing it. So they just do stuff with basic default or global design rules, and then they'll tweak things on the fly as they go through. And the reason why this is more than likely happen in the industry is that tools just don't provide a very good method for entering constraints. The process that you go through to do it is somewhat difficult. It's not very intuitive. There's no one central place in general to enter those constraints. You take even pads, for instance. The default way of doing stuff in pads is, yes, you can go to one place, but you have to go through several different little dialog boxes or buttons to get to those constraints. Altium is the same way, or even more complex for entering those design rules. Not sure about, depending on the OrCAD cadence flows, if you're looking at, if you have CES available to you there or not. But that's what I'm going to be showing you today, is that a lot of designers will end up using some type of spreadsheet or Word document for writing down their constraints to convey to the PCB designer. Obviously, if you're the electrical engineer doing the layout, maybe you don't have to do this, but still, you sometimes can't do it through the schematic. You have to wait till you get to the layout. So when you're doing the electrical design, you can't capture that content that is currently, running through your head. It could be days later and you might forget something. That should not have to be a process that you go through. So stop wasting time doing the same thing more than once. Why should I, again, put stuff in an Excel spreadsheet to pass along to the PCB designer in a Word document, or even my external resource that I'm using for doing PCB layout, okay? I've been designing printed circuit boards for 20 years, and I see this all the time, and talking to customers over the last 12 years, this is a very common practice. I don't know if it is with anyone else out there, but it is something that is seen in the industry. I should mention also, some people put constraint information, just typing it in on the schematic, and then the PCB designer has to interpret that. That should not be the process that you have to do, okay? And for those of us doing simulation type design rules where it requires a signal integrity tool or even analog simulation to define those constraints, why should you have to go to a second tool, define the constraint, and then import that information when you can, and recapture maybe the content that you want to simulate, when your schematic tool should have the ability nowadays to take the information right from your schematic and pull it into a simulation application so that you can run your scenarios and then create those constraints needed for the PCB design. And lastly, reviewing results is another big issue with a lot of tools. There's a lot of programs don't provide good feedback, especially for those doing more critical constraints like differential pairs, lots of link matching, features like that in the design. So there should be a process can be used to make those steps much easier. And for those pad users out there, you could use the little spreadsheet window in the pads router application, which is actually really cool and makes it simple, but you can't, you have to copy that information out and you have to give it to the electrical engineer if he doesn't have access to the layout tool in order to see that data. Well, that, again, should not be the process. If I'm an electrical engineer not doing the layout, I should be able to do a lot of these things that I just mentioned here without using some third, party process in order to do it. That's our kind of a focus today, is showing how the electrical engineer and even the PCB designer, we can make your life easier by using tools that are available to you today that you may not know about, or your tool that you're using today doesn't have the capability of even migrating to if possible. So I'm going to end the presentation real quick here, and we'll come back to that here at the end for some closing remarks. And I'm going to open up our tool here that I'm using today, which is VX Designer for Pads. It's actually called Pads Designer now with the VX22 release. Where I'm going to show you, for those users out there that are doing designs in Pad Standard Plus, there's an integrated flow function or way that you can create projects, okay? And that process allows you to use this Constraint Editor system that I'm talking about to do all of your design rules. For customers that are using Altium KiCad, AutoCAD Eagle, PCAD, if the people still out there using it, even OrCAD, flows. You know, this could be a way for you to simplify the whole process for you and your design flow. Okay, so let me go ahead and I'll search for a net here instead of me having to scan through my design. Maybe it's been a couple days since I've been in here. I can use this search application inside of the tool here to find a net. So I'm going to go for clock 35, and it will automatically do a search for me. I knew part of the name, so it didn't matter that I knew the whole thing. I can, it will start picking up things for you automatically. And if I scroll through this list, you'll see it found a net that happened to have clock_35 in it. And it shows me what pages it's actually on. And if I double click on that item, it will actually open that page for me. And you can see it's kind of highlighted right there. So I can zoom in on it and see, oh, there's my clock net. This is something I'm going to play around with for the purpose of this demonstration. But it just made it easy for me to find that net very quickly. So one of the things that I can do here is I mentioned the simulation side of this. Instead of me capturing this net or even worrying about, because this net's going all over the place on this, you can see it down here in this window, that this net's going to multiple pages. Instead of me worrying about what all the components are that are defined in this, for this net, from the schematic capture tool here, I can actually launch our hyperlinks signal integrity application, and I can do a verification on this net without having, again, to do all that extra work. So I can go in and see all the pins that are tied to this, some different nets, because it's picking up passive components that the net is flowing through, like a resistor or a capacitor. I can exclude some of those out if I don't care about them from that perspective, but I'm going to say go to hyperlinks. So it's going to take all that schematic information that I've already created, and it's going to push it into my signal integrity tool now, so that I can go in and play with constraints in this tool. So I could do things like looking at the stack up. This is a constraint that you need to enter into your PCB. And in this application, I can play around with impedance control. I can play around with how many layers are in the board, all of that information that I would need to enter as a constraint. And you're going to see that when I go into the constraint editor, actually. Okay, so I'm going to go ahead and cancel out of here. I can play around with lengths on net. So if I'm worried about the length of a net, or I can change the topology of this net in here, I can decide what layer this item is on. So I can say, well, I'm going to end up routing this probably on layer 5, so I can put it there, and then it will calculate the impedance for me. So if you see here, it's actually calculating on the fly the impedance, time of flight delay, items like that. Okay. Now you'll notice in here that my tool automatically assigned models to here. Of course, I preempted the capability to do that by let me go to one of these pages with the part on it. So this net's attached to this device here. If I go to my properties window over here, I pulled this information out of my library. So I put this data in my library. So when I added it to the design, I already had IBIS model information associated to the part to do my simulation. And we can do the same thing with analog simulation. Built into this tool is analog simulation capability. I can have all that defined and ready for me to go to do my simulation, to define what those rules are I'm going to place in my design. Okay, so this is just one aspect of being able to have an integrated solution that allows you to do stuff very quickly. I can play around with different scenarios for transmission lines, how these things are connected to each other to determine my topology. And then when I'm done with that, I can go back to my layout tool or my schematic. Being the electrical engineer, I'm the one that's worried about this. So I don't have to convey this on my schematic page. I don't have to write it in an Excel spreadsheet or put it in a Word document. Okay. Once I started capturing my design, I can launch this exact same rule system. Again, this is a logical, quick way to do things right from the schematic and start entering constraints. Okay. So let's do a quick navigation here of what this application is providing for me. So this is called the Constraint Editor system or Constraint Manager for doing all of your design rule entry. So I don't have to go anywhere else to see absolutely any of the design rules that I would define for my printed circuit board, other than a couple things like fan out processes and stuff like that. That's still done in the layout tool itself. Okay. So I can group nets together in classes. I can create different clearance rules, all the spacings between those items, and we're going to show how these get associated to each other and why the way this tool is structured is so important to make your life easier in sharing constraints. And then I can do all of my higher speed type things. So I can look at and set up my topologies, definitions. I can set up all my length rules, you know, whether I want a certain number of vias, information like that can all be found and set up very quickly. Once again, we're trying to make the process of doing design rules simple and easy and not complex. Okay, so each one of these groups here also has tabs in the bottom that I can flip between to find stuff. I can open up a parts window as well, and I can look at actual components in my design if need be. So here you can see, I can see every single part in the design. Our tool has the ability to pick up passive components and create what's called an electrical net. So instead of you having to worry about doing length matching for, say, termination resistor series terminators, I don't have to worry about length matching on one half of the net and one half of the other net. The tool can auto create what's called an electrical net so that I can, and this, whether or not the tool sees, you know, a particular component as an electrical net, and you can do it by reference designator as well. So those doing RF circuits don't want to think of the entire net as one big series. You can turn off the components you're using in those circuits. But for digital stuff, this is very important. And the tool will auto-generate these as well, which is another important aspect of making the process quick and easy. Okay, so let's go, how do we go about making a class? So in this application, you can see here when I just click on the main category name for class, it shows me all the current classes that are made. If I expand out each one of these, it actually shows me the layers for this design, okay? So now when you start the constraint editor for the very first time, it's going to ask you for what you think the board stack up's going to be for this design. You choose a template and it defines my stack up for me. So from there, I can start doing trace width information, differential pair spacing. When you launched into the hyperlinks tool, that stack up would have been used there, and you can play around with impedance numbers so that you can enter the proper widths for those particular items. Okay, so to create a class, again, it's very simple, very intuitive, just like a lot of other applications you'd expect. I do right clicks everywhere and get this stuff. I don't have to go to menus. So for this design here, I can click on new class. I can give that a name. We'll just call it test. You'll see that automatically popped up in there with its layer stack up as well. And then I can assign nets to this class. So you have a couple different ways you can go about doing this. I can right click there and I get a list of all the nets that are currently in the design, and I can assign them that way. Okay, and I can use some filtering features to assist with that down here. If I want to search for, let's say, just anything that starts with clock, I can need a star in there. So it would find me those nets that start with clock and highlight them, and then I could add them all at once. Or I can go over to my nets tab over here and have all the nets visible, I can search for them this way by scanning through the list, and I could select a group of nets and then do right click, say assign nets to net class, and say, okay, let's assign all these data nets to test. All right. Now, if I go back and right click over that, you'll see those have all been defined there. Okay. We can also cross probe with the schematic. So I've got a button up here for cross probing that will allow me to now cross probe with my schematic design. And I could go over into the schematic tool and highlight those nets. Or if you're in the layout even, you can go in the layout. You can highlight nets there and it will highlight them back in the constraint manager. So that's another way of selecting. So if you want to do it that way, you have multiple scenarios. You can see there again. Those nets were selected. I could group select them over here. And now if I go back over to the constraint editor, you see there it's selected all those nets. And again, you can right click. So again, very intuitive ways of doing stuff. This is one of those applications where you can hunt and peck around just by right clicking, and you can pretty much figure out how to use the application. There's not any real complex training that you'd have to go to understand how to create these. Okay. Now the clearance section. So in the clearance section, you're defining basically all of your spacing requirements. Again, you're doing it by layer. Okay. This is what, if you're a PADS user, would have been called a conditional rule. They were a little bit complex to create, but still easier than a lot of other applications in how they went about doing it, especially in Altium. So in here, I can clearly see the layers and all of the items and the from and tos for each object, okay? And then to change that constraint, I can either change an entire column by just typing in at the master level here. So if I want to change that rule to 5, I can hit enter and say, do you sure you want to override this? Click yes, and you can say everything changes to 5. Okay. Now I mentioned the ability to using a spreadsheet type environment for doing things, just like we would use Excel. Everyone's used to using Excel. They've done it at some point in time. This matrix works exactly like Excel. So if I really want all these items to be 5, I can take this top item. You see there's a little, let me try to zoom in here a little bit. There's a little box handle right there. I zoom back out. Hold my cursor over, it turns into a plus just like it does in Excel. I can drag that guy now all the way across the top here. Let's just go to here. Let's not do board edge. Those all change to 5, and now the entire matrix is fully changed to 5. Okay. If I want to change some particular things, on a particular layer, I can do that as well. So let's say board edge, all these items, I want to change that to 15. I can change this one to 15. I can drag that little handle again over here. And then you can even use copy and paste. So I can copy and I can paste those design rules. Again, just like using Excel, so very intuitive and quick. Okay. So what's the advantage of having an area where you're creating just clearance rules is that I can reuse design rules over and over again. Okay. So let's say for this analog class, I wanted a particular constraint set to go against this match track set and test. Instead of most applications where I'd have to go into this class to find a rule, and then I have to go into the test class to find the exact same rule, why should I have to do that when I already created it once? Let me just reuse it again. So we can open up what's called a class-to-class clearance matrix. Within this environment now, I can see all of my net classes that I've created in a matrix, and then I can use these cells to determine which clearance setup that I've created that I want between each one of these items. Okay, so my example was analog to match track. If I wanted that not to use the default rules and I wanted it to use analog to all, I can now drop that down and click analog to all. And I could do the same thing for test. Okay. But now if the analog nets were to route up against the clock differential pairs or any other net that's not part of a class, it's going to use the default rules. So this is, again, a very quick and simple and logical way to save or reuse your constraints. And so if I even make an adjustment to this constraint class, it automatically adopts all of those. I wouldn't have to go to each individual class and make that same design rule change, all right? That makes it much more complex and difficult to work with. All right, down here in our constraint class section, this is where I do all of my high speed design rule entry. So if I want to, like the async group here, you'll notice when I click on the Nets tab, that's basically the constraint class section. And right now here up at the top, I have a filter. So based on what I want to see in this matrix, I can filter those out. Right now I have everything turned on. And you can see in here, and I'm going to show you our Paths Professional tool as well. There's a lot of things that you could look at. Maybe you don't want to scan through that entire list all the time. You don't care about some of the items. All I care about is, say, length rules or differential pair as well. I can click on length. Now I can quickly see without having to scroll over what my length constraints are, and I can set those length constraints here, okay? I can do matching. So if I want to match a particular set of nets, let's go down to, I don't have a good group here. Let's make a new one. All right, so let me do, whoops, we'll do make a new constraint class. Again, we'll just call this class 1. All right, and then I'm going to assign a bunch of nets to this. We'll just use all these reuse nets here. Okay, so now if I go down to class 1, and now I see all of those nets. Now I could go in and say, okay, for this entire class, I want everything to be matched. Okay, and I can even do separate matching groups within the class itself by just typing in a name in here. So again, this doesn't have to be complex. I can call this G1 for group 1. And every other cell that I put in G1 in, and again, I can copy this or I can drag it down for multiple items. And then I could do, these ones are all G2. Grab that, pull it down. So now when I set a tolerance for length matching these, let's say I need all these within 50 thousandths, you notice it automatically fills in the tolerance field for them. I don't have to do each one individually. That, again, would be a waste of time. And these ones all need to be 25. Boom, done. So now I have a length matching class that I created groups on very quickly and set their margins with each other. Okay, I don't care about their overall length. That's why this is set to, 50 inches. All I care about is that they're matched within each other. Now I could do a min and a max length requirement on those nets if I wanted to for this design, and then they would fall within between in that category, plus they would have to be matched within this category. Okay, but again, it's very quick and easy to do this by just viewing the classes in this navigator tree, which all the tools are using now. Go back to DX Designer. I have the same thing for navigating around in my schematic pages. In the layout tool that I have open in pads here as well, I can open up a navigation tool and I can see all of my nets and pick on them in there. Pads router has the exact same function. So every tool has this nowadays, even, the Altiums and OrCADs and other applications as well. So nothing new there. We're very used to it. All right. Now, another feature that I'm showing here that helps with the whole review process. So you as the electrical engineer, once the PCB has been started, don't know if the PCB designer has actually followed your design rules. You're hoping they're doing the right thing and using their DRCs to do so. Why shouldn't you be able to see all of the length information based on what they're doing? And you can do this at any time. So you can pull up your schematic after the tool has been worked on, or the layout has been worked on, and the placement's done, or the routing's been started. And I can go to the data field here, actuals, and say import actuals from the layout, and it will bring into the constraint manager environment you started from the schematic all the actual length information for you. Okay, so now I don't have to rely on talking to the PCB designer to see my length information, and the tool is even flagging if a net is violating a design rule that you created. Okay, and there's some help there as well. I can do constraint violations, and I can set up information, or I can see globally very quickly what rules have violated my constraints. Okay, it even gives me a count and all of that. Now I can go back to my PCB designer and say, hey, let's review, the length rules I've set up for my diff pair class, and go through and find out why they're not routed correctly. A nice feature is being able to see the Manhattan length of a net, which is kind of a gross way of finding out how long it's going to be, but it does give you a general idea that you can use as a guide for even creating your length matching rules based on the placement. Okay. By the way, as I've mentioned, hopefully at the beginning here, that everything I'm showing you here is the exact same on the PCB side. So that's, again, a huge feature or function that makes it easier for both of you to talk to each other and work together, that your rule entry process is the exact same on the schematic side as it is on the layout side. And if you're the electrical engineer doing the PCB layout, why wait until the end or until I get over into the layout tool to do my constraints? I can do everything beforehand when I'm thinking about it. I could draw in a net in my schematic and go, you know what, I need a certain constraint on this, this net clock in net here. And I want to define that right now while I'm thinking about it, while I have the data sheet open. Okay. I can actually, if I don't have the constraint editor even open yet, let's go ahead and close that. While I'm working on this net, I don't even have to worry about opening the constraint editor from that button. I can right click over this. Sorry, that's a Pads Pro advantage. I can cross probe though, but I can just come up here and hit the constraint manager button. That would launch the tool. Obviously, on the Nets tab, I can go back to all here, go into my schematic, and click on that net that I want to do something with, and it will cross probe into here. And now I can start working on that net and setting its length constraints if I need to. Okay. So all the gray fields that you see here are fields that cannot be edited. They're just information that's being fed back to you. All right. Only the light colored fields, like in Excel, are the ones that you can enter content in. All right. So let's talk about another design aspect that can be a little difficult to deal with if you're doing differential pairs. Okay. Now I could go into the schematic. Okay. I'm just going to zoom in here. I'm going to click on a net, and through the properties window here, we could go in and I could, pick the other net that's going to be part of that differential pair. And actually, let me go ahead and do that just to show you how real time this really is. I'm going to say, go down to the IMP net and choose A2. So in the schematic here, I've defined a differential pair just by choosing its partner object there in that list. Now, if I go back over to the constraint editor and click on all and say, let's just look at differential pairs, you'll see that net popped up for me instantly. that shows you that, again, the interaction between the two, that net now exists in here as a differential pair without me even having to worry about coming in here, and I can filter for it very quickly to find it. Okay. Now in this case, I'm going to get rid of that constraint because I don't want that. We'll just remove this. Okay. And now, as you expect, I go back here and that differential pair is now gone. Okay. But if we're doing intelligent naming of our nets, like most engineers do for differential pairs, they'll do some type of, like this example here where you've got the N's and the P's here. We can have this constraint editor system, or the constraint editor system should be able to find this type of stuff for us automatically. Again, making this whole job very simple. Okay. So up here in our toolbar, I can go to auto assign, or I can go to the edit menu, differential pairs, and choose auto assign. But when I click on this button, this gives me a dialog box now that I can use for searching for additional, or searching for those nets that need to be differential pairs. So if my naming scheme is _P_N, I can click on that. Oops, I already forgot I had these already created. Let's just go ahead and delete these. Just to show how this works. Let's get rid of these real quick. Go back up here and do that again. Okay. It will go and find all the net pairs, if you haven't, differential pairs that already have not been created, pick them up for you, show you how they're going to be defined based on their naming scheme. And then I can hit apply, and it creates them for you automatically. So I could literally create hundreds of differential pairs with a couple clicks of a button with this type of constraint management system. Again, saving me a tremendous amount of work and time. Okay. And then obviously once they're here, I can add these to net classes or constraint class if I was on the alt tab to help me auto-generate that information as well. And then I can go in and define my rules. Okay. So like up here, differential pairs, I can set up my diff pair spacing by layer, knowing that my stack up is obviously the trace widths on the top and bottom are not going to be the same as they are in the middle of the layer. Okay. So all of these things help streamline the process of creating constraints, making it that task that is something that I don't want to do, and just go in and create default constraints and adjust stuff on the fly. There's no point in doing that. When you have a constraint editor system that makes the job quick and easy, define all your constraints before you start routing the board, placing the board, and move forward from there, and then adjust things. Being able to use the constraint management system for doing critical length matching, design reviews, and looking at the design while it's being worked on, all in one central location. So again, the whole process is simplified. Okay, just a couple other additional things in here. You can enter some global design rules for an entire board. We can enter 3D constraints in as well. Let's see, where did that go? I'm not sure where the button went for me here. It should have been right there, but as you know, pads now supports three-dimensional placement capability. And in this tool, you can define, or in the constraint editor system, you can define all of your 3D constraints, okay? So that you're not having to wait to get into the PCB space to do that. And you can do things like component to component, component to assembly. It allows you to do real-time three-dimensional DRC verification in the layout application while you're placing parts. Okay, so this is a generalized overview of Constraint Editor creation capability. I'm going to close out of the pads version of the tool here. And, like I mentioned, you can get to the same application from the pads layout application. You can open up pads router, get to the same application to do your constraint entry as well, if you want to adjust stuff on the fly. Okay. Another nice feature that's been introduced in the industry is the ability to know when something's being changed. This is just a highlight real quick. So if you're an electrical engineer not doing PCB design, you want to know if things are being changed in the constraint editor system. On the schematic side, even, there's some indicator buttons down here in the bottom that will tell you, oh, there's been connectivity changes, I need to update the layout, or there's been schematic constraint changes, the engineer made changes, I need to import those or contact him and find out why. If you're the electrical engineer not doing the layout, if the PCB designer makes constraint changes, you have the same indicator, and you can tell the PCB designer to do a synchronization. So there's an integration function that you run to synchronize the layout and the schematic, so that everybody's seeing the new content that's been introduced. Okay, so let's go ahead and exit out of here again real quick. And I'm going to go to Pads Professional here real quick just to show you some additional capabilities that would be available to people if they're designing boards that need to be more highly constrained than what Pads has the capability of doing, or even OrCAD CIS Flow, or OrCAD Allegro Flow, or even Altium for that matter. So again, this is going to be the exact same schematic. It's all the same environment. So if there's anyone out there that is interested in migrating into this environment because you're doing more difficult designs, it's just upgrading your tool, and your schematic environment will all be the same. If I launch the layout application, you will notice it's a little bit different. It's based off of Expedition technology, but to that advantage, it gives you some power that is currently not available in pretty much every other layout tool in the market today, with technology that works well and fast, and auto router technology, again, that works well. Okay, so this is the layout application, Pads Professional Layout. As I mentioned, this is a tool that provides more advanced capabilities for doing difficult designs. If you're doing a lot of gigabit I/O, length matching in the DDR space, a lot of high-speed GPIO between FPGAs or connectors, PCI Express, things of that nature, this application can provide advanced technology that no other application really has the capability of doing without going to a full enterprise Expedition flow. Okay, so if I go ahead and launch the Constraint Editor system from in here, and this one has the advantage that I was trying to show in the Pads one, where if I click on this net and I want to see that net in the Constraint Editor, I can just right-click and choose Edit Constraints from the right-click menu, and it opens up a built-in window for actually looking at your constraints. So no longer do I even have to bother going to the manager tool. I can just click on a net and see those constraints right here in this window. I can adjust the constraints. I can change items on the fly to do my design rule process. And if I'm making updates to a design that's already been started, if I do a update to the constraints here, the PCB designer will be notified again via the little indication lights down in the lower right-hand corner of their window. And they can simply hold their cursor over it, see that there's updates, and they can double-click on that, and it will automatically launch the update process and update their design. So again, making it very quick and easy. Okay, same capability of going to hyperlinks as well. All right, but if I open up the Constraint Editor from here, just like I would in the Pads flow I showed a little bit earlier, you have all the same capability, okay? It looks all the same, except we've got an added item here called schemes. This is where, again, when things get a little bit more difficult in a board design perspective, like using a fine pitch BGA or even SOIC or quad flat pack, and you need to specify rules around that part, Expedition and PADS Professional have that capability. So I can create what are called schemes, or what would be a rule area inside my layout. So like this area right over here is a finer pitch BGA, and I need to define rules that are a little bit more specific to this area, where the trace width is going to change as I migrate across that area. Okay, in this case, I'm calling it FPGA. And again, I have all my net classes available to me. So for particular nets that are coming out of there, I can specify rules by layer just under that part. Okay, so that's what rule schemes are, is you're defining those rule areas on the PCB, again, to make your life easier. So as I, pull an item around, it's going to automatically change as I cross that boundary for that particular area. Okay. Everything else is pretty much the same, other than when I go to my constraint rules. Again, I'm showing, I have all my typical constraints there, except now I can specify a little bit more information about impedance. Okay. In fact, from the constraint editor in here, I can actually launch the stack-up editor instead of having to wait to go into hyperlinks. I can define everything in here. When you do it through the schematic side, you can't change the stack-up, but if I launch this from the PCB side, I can adjust the stack-up using this stack-up editor, do all my calculations right here. No need to rely on third-party web tools or anything of that nature. It just defines it all for you here. Okay. And if I go down to my clearance classes, I have a lot of the same stuff here as well. So I have all my clearance design rules, everything's the same, except you're going to notice I can do my clearance rules again by scheme. So we didn't see these when I went into the constraint manager for pads, but in here I have that rule area capability. So I can define a set of rules under the FPGA versus everywhere else on the board. Okay. And another neat feature that's available to you from a reporting perspective is the ability to see what the minimum rule is. I've defined all these constraints in my constraint editor, but I don't know where I actually put my minimum on any given thing. You can just expand the minimum group, and this will be filled in with all the minimum design rules you have. So now when I do my documentation, I know exactly what my minimums are. Okay. And if someone changed something incorrectly, like the electrical engineer didn't quite know what the minimums were, and he put in a rule that didn't meet fabrication guidelines, you can quickly find those and go back and adjust them. Okay. Now, if we look at the nets information in the constraint classes here, there are, again, some new additional ones that can be used. Expedition, or the PADS Pro, understands backfilling. You can restrict lengths by layer. So if I only want certain lengths, trace lengths on the top and bottom layer, I want it mostly routed on the internal, I can specify those. You can actually enter time of flight information. So instead of just doing all length stuff, I can actually put in time. So now instead of saying, my minimum is going to be 1 inch, I could say, well, my minimum time delay is 1 nanosecond, and my maximum is 1.2 nanoseconds. And the tool will figure out the length for you. No need to worry about doing the calculations yourself or using hyperlinks. Just enter the rule as a timing data. Very useful for the electrical engineer, which understands all of the timing information. Okay. We keep scrolling over. We'll see we have other items. We can do formula-based equations. We can set some simulation constraints, actually, that would be used in hyperlinks. Okay. That's another advantage of the Pro Flow is instead of me waiting to go to the schematic to enter stuff, I can actually launch LineSim directly from CES. So from the Constraint Editor, while I'm entering stuff, I go, you know what, I need a length information for this, but I don't know what that's going to be. I can just select the net. I can launch that net into the hyperlinks tool that comes with the Paths Professional application, and now I can play around with, you know, the stack up and what layer this net's going to be on, and timing information, and then go back and enter that information in my length or time of flight information data. Okay. We can do more complex topology definition. So let's look at routing. Here's the number of pins. Here's a net with 4 pins on it. I expand this out, I can see all the pins. If this was to be something critical where I need to control the topology on here, I can do that simply in here. I don't have to wait to go to the placement tool to define this. Again, I can use my simulation application, do all the definition, and then I can say, okay, this is going to be a custom or complex definition. And then I can come up here to my toolbar for netline ordering. I can click on netline ordering, and now I can define the order of which these nets need to be routed in the PCB. Okay, so I can say, okay, this net needs to go here to that one, add that, and then maybe I want this one to go to this one, and then, but maybe I want this one to go to this one. And I can define all my pin pairs, click OK, and now those definitions will be passed into the layout. Okay, so you as an electrical engineer, again, have a lot of control over that type of definition without relying on passing that information along to the PCB designer. And he'll see the netline ordering when he places the parts if he puts the part in the wrong spot. Okay, also very useful, again, for design reviewing the board, so you can see where the pin pairs were routed correctly or not. As another advantage to this, you can define what we call virtual pins. So if you're doing any DDR circuits and you need to control length matching, say an address line to all the chips, or you're doing some difficult clock distribution network, you can, again, define a complex topology, and the tool will add what's called virtual pins. So again, if I expanded this out and set this to complex, go into definition, I can make a group out of this. So I can, let's see, I want to do a T topology on that and add that. Actually, that requires 3 nets. Let's grab these guys and let's just do a chain topology. Oops. Nope. Should be allow me to create this pin set, but the idea here is I'm grouping several pins together into a changed T or balanced topology, and then I can even group those 2 pin sets against each other. And what the layout tool will do for you is it'll place what's called virtual pins, or allow the designer to move around a via location that's going to act as a pin. And now you can define length constraints between an actual component pin and a virtual pin. Again, letting you do more complex rule definition. Okay, so those are some added functionality that's available if designers out there are doing very complex constraint definition that may not be allowed in the tool you're using today. You know, you can move into an application that allows you to do these very difficult constraints, but not pay an exorbitant amount of money for that application, which is what the Paths Professional tool flow was really created for. It gives you the power of enterprise level applications like Expedition and Cadence Allegro, at an affordable price. Okay. So that's pretty much what I wanted to show today. How, you know, there are tools out there that can make this process of designing rules very quick and easy, and not have to worry about this being a pain or doing secondary documentation or anything of that nature to define constraints. Okay. Let's see if I have any questions here. Let's see, here's one. Someone's asking, is there the capability to create subclasses underneath the main class? Actually, there is. So I could take, say, like this data class here, or let's create a new clearance group. Again, I'll just use test to make it easy. Actually, I want to do constraint class. Assign a bunch of nets to this. Just going to grab a bunch of random stuff here just to make it easy. Okay. All right, and then under that, I can make a subclass. So now I could break this up. So like, say you're doing DDR. In fact, let's just go back and rename this. We'll just call this general DDR. Okay, and I want to make a couple subclasses. Oops, I don't want to rename that. I want to new. So I want to create data 1. If I could spell. And then I want to create data 2. And then I want to create a subclass, you know, called control. Okay. And then I can add all the nets from this major class into this subclass. And again, make it easier for me to work with these nets in the future. Okay. My assigned net process didn't work there. Let's do all these IMP nets. I don't think these are assigned anything. All right. So now I have a bunch of nets assigned to that. And then for data, I could say assign nets. And I could filter on DDR and add in, you know, the data nets into that class. Click OK. So now I have that subclass. Again, it just makes it easier for you to work with your constraints instead of having to filter through a big list, set up match groups, and such based on that. Okay, so yes, there is subgrouping capability. Okay, and this goes as far as also length matching. You know, I could set up a length constraint for this data class. You know, I could set up a max length for this group. If I go to lengths and delays, I could define, you know, what my minimum maximum lengths are for this set, but I could have a, you know, another set of rules that sits over the top of that. So the tool will it will match to these, but it also has to fall within the master constraint class itself as well. Okay. So again, those are kind of getting into more complex things, but the tool should have the capability to do it if you need to do it and not make the process complex like most applications, like an Ultium tool. This type of stuff to do in that application is very difficult or can't be done at all. Okay. All right. I don't see any other questions off the top of my head here, so let's go ahead and just do a quick wrap up on the presentation. Get back to where we were. So a little recap again. This webinar will be live online, or archive of it will be available for you to refer back to at any point in time, or pass it around to colleagues. You know, feel free to share it on LinkedIn or Facebook or the email, anything you'd like there. And as a bonus for you attending and registering for this webinar, we're offering a buy now option with a discount using this code. So if anyone out there wants to write that down, that's interested in looking at these tools further and maybe taking advantage of a discount, feel more than free to do that. You can contact myself, Fawn, or any of those people I mentioned at the beginning. This presentation will be PDF'd and emailed to you as well, so you'll have this to refer back to in the near future. And then lastly, we have another one coming up next month. What's new in the PADS release that basically customers have asked for. So this VX 2.2 release, a lot of functionality and things added to the tool were based on you, the users, using the Mentor Ideas function to add new capabilities to the schematic PCB, layout tools, the simulation tools as well. Okay, let's see, I think I got another question here. How to keep track on the constraints order automatically, save as a new revision. No, the Constraint Editor does not keep constraints from a revision perspective. So that would be something. It does remember them. So there is a rollback feature in the tool. So if you ended up making some constraints and you wanted to roll back to the last time you opened the tool or the design, you could use the rollback function, but there's no revision check-in or revision specific history that you could tie into at this time. Okay, the full Expedition Enterprise Flow does have that capability with their data management application, but the Pro and PADS do not, unfortunately. Good question. Thank you for asking. All right, well, let's go ahead and wrap it up. It's been about an hour. Went a little longer than I expected, but hopefully this was good information for everyone. I want to thank you all for joining and look forward to seeing you at another one of our Did You Know webinars. Thank you very much, and goodbye.